Hello, 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 testing. 6 times 6, 2 times 3, 2 times 3. Okay, good morning, everyone. So today we're going to be solving quadratics again, but this time we're going to be doing it in a different way. Instead of factoring, we're going to be using the quadratic formula. Now, I'll go over most of these vocab terms when I come back, but for today, the important thing is that we know the quadratic formula. So I'm going to write that here. It goes x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so just jot that down, and we'll talk about how to use it in a little bit. But because of this square root symbol in the quadratic formula, the first thing we need to do is practice simplifying square roots. So that's what we're going to do here. Now, the first one says the square root of 36. Now, as you can see on the left here, 36 is a perfect square. And if you remember, you can just go straight to the answer on this one and say that the square root of 36 is 6. But if we forget, or if it's not a perfect square, there's another method to get to this answer, and that's what we're going to look at now. So what we want to do is break down these numbers into their prime factorization. So what that means is we're going to start by any two numbers that we know multiply together to get 36. So we can do 3 times 12 or 6 times 6. Now we're going to keep doing this until we can't break them down any further. So each of these 6's that I know multiplies to 2 times 3. And this 6 is also 2 times 3. So what I'm going to do now is rewrite the square root of 36 with its prime factors instead. And I'm going to put them in order from least to greatest. So I'm going to rewrite this as the square root of 2 times 2 times 3 times 3. Now, what we're looking for when we do these are pairs of the same number. So what I see is that I have a pair of 2's here and a pair of 3's here. And those we are going to pull outside of the square root. And if we ever have more than one pair, we're just going to multiply them together. So we multiply 2 times 3, and we get 6. And we're going to continue to do that for the rest of these problems. So we go over to the next one, 32. Now you can start with any two numbers you want. We can do 2 times 16. We can do 4 times 8. It really doesn't matter. I'm going to use 4 times 8. Then I break down 4 to 2 times 2. And I can't do that any further, so I'm going to stop. Sometimes I like to underline the ones that I can't go any further with. Now I'm going to go to 8. It's 2 times 4. And 2 is done, but I can break down 4 some more to 2 times 2. So again, all the ones that I've underlined, all the ones that I can't break down any further, I'm going to write inside of the radical. So here I can see I have 5 2's, 1, 2, 3, 4, and 5. And again, what I'm looking for are pairs of the same numbers. So I have one pair of 2's here. I have another pair of 2's here. So both of those are going to go outside of the radical. And I'm going to multiply them together when I do pull them out. So this is going to become 2 times 2, which is 4 on the outside. Now this time, unlike the other one, I have an extra one left inside the radical. And I'm just going to leave that one in there because it didn't have a pair to be able to pull out. And there we have 4 square root of 2. And that's our final answer. We can't break it down any further. So go ahead and try these next two. You can hit pause on this video. And then when you're done, hit play again, and I will go over how to do them. So square root of 50. Again, on this one, we can do 2 times 25, or we can do 5 times 10. You're going to get to the same answer either way. I'm going to use 5 times 10. Now 5 I can't break down any further, so I'm going to underline. 10 is 2 times 5. And again, both of these I can't break down any further. So I'm going to rewrite this. Square root of 2 times 5, and I see I have a pair of 5s that I'm going to be able to pull out. That goes on the outside, and then what's left is a 2. And that is your final answer. One more here. Now, with the bigger numbers, one strategy you can take is sometimes it's hard to figure out what multiplies to these bigger numbers. But if it's an even number, we know that it's always divisible by 2. So you can use your calculator and just try and divide it by 2. Now, if it's not even, just try a bunch of numbers. Just use your calculator, try to divide it by a bunch of numbers, and see what you get. Here, I know that 288 is 2 times 144. Now here, you might remember that 144 is 12 times 12. But if you don't, again, you can use any two numbers that you know multiply together to get 144. I'm going to keep going. 4 times 3. 4 times 3. 2 times 2. 2 times 2. Now again, I'm looking at all of these numbers that I can't break down any further. So here, this becomes the square root. I have 1, 2, 3, 4, 5 2's. And I have 1, 3. So I'm looking for the pairs. Here's a pair of 2's. Here's another pair of 2's. So this time, I have 2 pairs of 2's. Those are going to go on the outside. I'm going to multiply them together and get 4. And now I have 2 numbers left on the inside that I was not able to pull out. And so what I get is 2 times 3. I'm going to multiply those together and place them back inside the radical. And this is my final answer. So the reason we're doing this, if you look below, we have these problems here where there is a radical inside the rest of an expression. And this is what they are going to look like when we use the quadratic formula. And so here, all I'm going to do first, and this is always the first step, is to simplify what's inside the radical. Now, square root of 4 is something that you should know is 2. So that's the first thing I'm going to do is just simplify this and make it 10 plus or minus 2 all over 2. All right, I just rewrote the expression, but I simplified the square root of 4. Now, you might be wondering what the deal with this plus or minus symbol is. And all that means is at this point, we are going to split it into 2 expressions. One where we write 10 plus 2 over 2, and the other where we write 10 minus 2 over 2. So I'm going to do that now to write our final answer. One of them, 10 plus 2 over 2. This becomes 12 over 2, or 6. And then the other one, 10 minus 2 over 2. That becomes 8 over 2, and we get 4. And those are our final answers. This next one is going to be slightly different because the square root of 8 is not a perfect square. So we're going to need to use the tricks that we just learned in order to simplify this. And that is always the first step. So I'm going to create a little scratch work area over here just to simplify the square root of 8. Square root of 8 is 2 times 4, and 4 is 2 times 2. So this becomes the square root of 2 times 2 times 2. We have one pair of 2's. That goes on the outside. And this one that we were not able to pull out stays on the inside. And now all I'm going to do is go back to the original expression, and where there was a square root of 8, I'm just going to replace it with its simplified form, which is 2 square root of 2. So we get negative 6 plus or minus 2 square root of 2 over 4. Now for this one, because it didn't simplify to a whole number, we're not going to bother splitting it up into two separate expressions. What we do want to do is simplify if we can. And what we're looking for when we simplify these expressions are these numbers. And we just ask ourselves, is there a common factor? Is there something that divides all of those numbers? And in this case, I know that all of those numbers are divisible by 2. And so that's what I'm going to do to get our final answer. It's going to become negative 3 plus or minus 1 square root of 2 all over 2. And this is the completely simplified form of that expression. Now, if you wanted to know what this value was, you could plug it into the calculator. Negative 3 plus the square root of 2 over 2. And the other one, negative 3 minus the square root of 2 over 2. But that's not necessary. For this class and for most classes, we're just going to leave it just like that. And that's an acceptable final answer. So now we're going to look at how we can apply this concept to solving quadratic equations. And for that, we need to use the quadratic equation. So I'm going to rewrite that here, and I suggest you do the same. X equals negative b plus or minus the square root. Okay, so what we need to know before we start using this quadratic equation is what the standard form of a quadratic equation is. And standard form of a quadratic equation looks like this. It is a x squared plus bx plus c is equal to 0. So there's a few important things here. One is that the equation always needs to be equal to 0. If it's not equal to 0, then we need to do some work to get it to equal 0. But if it is, then all we need to do is figure out what these a, b, and c values are. So the a value is always going to be the one that is next to the x squared term. Okay, so in this case, the number next to the x squared term is a 2. The b value is always going to be the one that is next to the x term. And in this case, it looks like there is nothing there, but in fact, there is a 1. And then finally, the c value is going to be the one that is after the x term. And in this case, it is negative 15. So all we're going to do at this point is plug those values into this quadratic equation, and you can see it's written for you again right here. So negative b is 1, so we're going to place a 1 here. Plus or minus the square root of b squared, so that's 1 squared, minus 4 times a, so we're going to put a 2 there because that's our a value, times c. So we're going to put a negative 15 here because that is our c value, all over 2 times a. And again, a is 2, so we put a 2. And now all we're going to do is start simplifying. And what we are focusing on first is just this square root part. All right, that's why we were practicing simplifying square roots so much, is we want to be able to simplify that. So I'm going to figure out what the value is underneath that square root, and then I'm going to start simplifying. So you can just take this part of it and evaluate that. If you need to use a calculator, you can. But go ahead and try that now. I'm going to write the rest. This becomes negative 1 plus or minus. And again, all we're doing is simplifying what is underneath the square root. So 1 squared minus 4 times 2 times negative 15. Go ahead and punch that into your calculator or figure out what it is, and then we will continue. So what you should have gotten is 121 over 4. I did simplify that bottom part as well. So now what we want to do is go over here in our scratch work area and simplify the square root of 121. Now, this time there is only one way to break down 121, and that is 11 times 11. So we rewrite that under our square root, 11 times 11, and we see that we have one pair of 11s, and that is going to come outside. And there's nothing left on the inside, so we don't need to write anything else. So this becomes negative 1 plus or minus 11. That's what the square root of 21 is, 121. And now we can split this one into two expressions and simplify both of them. So here I'd have negative 1 plus 11 over 4. That becomes 10 over 4. And this one, we cannot, 4 doesn't go into 10, but we can simplify this slightly. Both of those are divisible by 2, so we get 5 over 2. And that is one answer. Now we're going to do this one more time, but this time, negative 1 minus 11 over 4. This becomes negative 12 over 4, or negative 3. And those are our two answers. Okay, so on this next one, you can see that it breaks our first rule. Remember, the standard form of the quadratic equation is this. And it has to equal 0. In this case, the equation doesn't equal 0, it equals 8x. So what we need to do is subtract 8x from both sides. We get 3x squared minus 8x plus 5 is equal to 0. Notice when I subtracted the 8x, I didn't combine it with the 3x squared. I didn't combine it with the 5. It's its own term. It can't be combined with the x squared term or the constant term, which is the 5. It just needs to be placed right in the middle of the two. So now we're going to go to the next page. We'll rewrite this equation. 3x squared minus 8x plus 5 equals 0. And we'll go ahead and start plugging these values into our quadratic equation. If you want, go ahead and pause the video now. Try this one on your own, and then you can hit play again to check your answer. So here, A is 3, B is negative 8, and C is 5. Plug these values in. Oops. Negative 8, negative 8, 3, 5, and 3. And then again, we're going to go ahead and start simplifying, focusing on what is inside the radical. Now, in this one, one thing we want to do is notice that here we have two negatives. Those are going to cancel each other out and become positive. So we have a positive 8 plus or minus. This becomes 64. Now, minus 4 times 3 times 5. Now, you don't need to write that part. We can just go ahead, use your calculator, use whatever you need, and figure out what the entire thing is equal to. You don't need to break it down. You can do some scratch work off to the side, but just figure out what that entire thing is equal to and then go from there. So what I get in this case is 4. Whoops. Oops. Then over 6. All right, now this one's pretty easy. We don't really need much scratch work. I know the square root of 4 is 2. So I'm just going to write 8 plus or minus 2 over 6. And then I'll go ahead and split those up. This becomes 8 plus 2 over 6. We get 10 over 6 becomes 5 over 3. Or 8 minus 2 over 6, we get 6 over 6, or 1. And that's it. That is both of our answers. All right, we have one more here to look at. Now, again, this one is not set equal to 0. This time the constant term is over on the right, and we're just going to add it back to the left because it's negative. That gives us x squared plus 3x plus 4, and again, I can't add it to these other terms. It's not the same kind of term, and so it just goes right there on the end. So that's the equation that we're going to solve now. A is 1, B is 3, C is 4. And again, go ahead and pause this before I do it and see if you can do it on your own, and then check your answers. So we get 3 here, 3, 1, 4. All right, so here we have something interesting, which is a negative underneath the square root. Now, when this happens, there is no need to continue simplifying. There is no real solution to this quadratic equation. Now, if you take Algebra 2 next year, you'll learn that there are what is called imaginary solutions, but we are not going to deal with finding those in this class. So if there ever is a negative underneath the square root, we can write no real solution. All right, so that is it for solving quadratics using the quadratic formula. You guys can go ahead and work on the idia assignment.